Imagine standing on Mars 3 billion years ago. The sky isn't red, it's thicker, hazier. You're in a massive valley, kilometers wide. And below you, you can hear it, the rush of a brown river winding through the landscape. Storm clouds gather on the horizon. This was Mars. So how do we know these rivers were real? And what happened to all that water? Today, Mars is a frozen desert. The average temperature is a brutal -60 Celsius. The atmosphere is so thin, it's barely there, less than 1% of Earth's. There are no rivers, no lakes. Just dust, rocks, and ice. But if we roll the clock back 3 to 4 billion years, we're looking at a completely different world. During its Nochian period, Mars had a wetter climate. Valley networks carved through the highlands. Craters filled with lakes. There might have even been an ocean covering the entire northern hemisphere. This wasn't the planet we sent rovers to explore. This was a different Mars entirely. So how do we know this isn't just wishful thinking? The evidence is literally carved into the surface. First, there are the valley networks. These are massive, branching systems that look exactly like river systems on Earth. They aren't random cracks. They're organized, flowing downhill and merging together just like tributaries. Second, we have fossil deltas. Jezero Crater, where the Perseverance rover landed, contains a stunningly clear ancient river delta that once emptied into a lake. You can see the fan-shaped deposit where the river slowed down and dropped all its sediment. And then there's the sheer scale of what we've found. Recent surveys discovered over 15,000 kilometers of fossil riverbeds in just one region called Noches Terra. That's a huge network of massive rivers. And here's the real kicker: several of these Martian rivers were twice as wide as comparable rivers on Earth today. These weren't tiny streams. These were colossal rivers, carving through an alien landscape billions of years ago. Let's zoom in on one specific place, Jezero Crater. 3.5 billion years ago, this wasn't a dusty crater floor. It was a deep lake, maybe 40 kilometers across. Picture the scene: a powerful river flows down from the highlands, carrying sediment, clay, minerals, and maybe even organic molecules. As it enters the lake, it slows down and spreads out into a delta. The sediment settles in layers, year after year, century after century. Then, when the lake gets full enough, water spills over the crater rim on the opposite side, carving a brand new exit channel. This is exactly why we send the Perseverance rover to Jezero. River deltas are sediment traps. They're perfect for preserving biosignatures, the chemical or physical traces of ancient life. If microbes ever lived in those waters, the delta sediments are one of our best shots at finding the proof. But here's the big puzzle: how could liquid water flow on a planet that's so cold and has such a thin atmosphere? Scientists have two main ideas. The first theory suggests Mars was globally warmer and wetter. With a thick atmosphere that created a powerful greenhouse effect, rain fell, rivers flowed, seasons changed. For hundreds of millions of years, it was almost Earth-like. The second theory paints a different picture. Mars was mostly cold and dry, but with short, intense warm periods. Maybe a massive volcanic eruption pumped greenhouse gases into the air, or a giant asteroid impact melted the surface ice. These catastrophic events would have created brief windows, decades, maybe centuries, where water could flow. We're still figuring out which version is closer to the truth, but either way, those rivers were real. Now, here's where it gets really interesting. Around 3.7 billion years ago, something incredible was happening on Earth. The first microbes were possibly emerging around hydrothermal vents. At roughly the same time, Mars had rivers, lakes, and mineral-rich environments with liquid water and chemical energy. All the essential ingredients for life were there. And just recently, Perseverance found something intriguing in Jezero Crater, a mudstone sample containing minerals that could be associated with microbial processes. A possible biosignature. It's not proof yet, but it is very, very promising. What if life didn't just emerge on Earth? What if it started into places at once, onto neighboring worlds? What if we're not just looking at a dead planet, but at the fossil of a living one? So if Mars once had these massive rivers and lakes, where did all that water go? The answer is written in the planet's slow, tragic death. Early in its history, Mars lost its global magnetic field. Without that protective shield, the solar wind, a constant stream of charged particles from the sun, began to strip away its atmosphere. As the atmosphere thinned, the pressure dropped. Liquid water could no longer survive on the surface. It either froze solid, evaporated into space, or sublimated directly from ice into vapor. Over hundreds of millions of years, Mars transformed from a world of rivers into the frozen desert we see today. But here's the thing, not all the water is gone. A lot of it is still trapped in the planet's crust, as buried ice or maybe even salty liquid water deep underground. Mars didn't lose everything. It just went to sleep. Today, when you look at Mars from orbit, you're seeing ghost rivers. Dry valleys that once carried torrents of water. Eroded deltas that once teemed with sediment. These are frozen photographs of ancient floods. If you could fly over ancient Mars, it might have looked weirdly familiar, almost like a rust-colored version of Earth's Colorado River or the Nile Delta. The water is gone, but the memory remains, carved into stone. Every crater tells a story. Every valley is a chapter in the history of a world that almost made it. So what happens next? Right now, Perseverance is mapping the ancient rivers of Jezero, drilling into the lake sediments and the delta deposits, and collecting samples in sealed tubes. Those precious samples are sitting on the surface of Mars, waiting. The plan is a mission called Mars Sample Return, which will bring them back to Earth. Here, we can analyze them with instruments 1,000 times more sensitive than anything we can send to Mars. There are challenges, debates, and funding issues, but the mission is moving forward. And when those rocks finally arrive in our laboratories, we might be able to answer the question definitively: did life ever exist in the rivers of Mars? Massive rivers flowed on Mars 3 billion years ago. And somewhere in these dried-up valleys, buried in ancient sediments, we may find the answer to one of the biggest questions we can possibly ask: were we ever alone? If you want to dive deeper into Mars exploration, check out the links in the description below. And if this got you thinking, hit that like button and subscribe for more. Thanks for watching.